So, welcome one and all. So, in this lecture, we will discuss the activity based upon Excel, Microsoft Excel. So, in this activity, we will discuss the following things, or we will execute these. Whatever you are saying on the screen, we will execute these. So, first of all, data generation, one can very well see here data generation is there. So we will create a data set of n equal to 1000 random numbers which follow a normal distribution whose mean is 30, mean mu is 30 and standard deviation sigma is 4. Okay. So for this, if I show you, here, this is the screenshot of this. So you can see here. So here I have selected this portion. Now you can see this column I have selected. So here, this is the required data. Okay. Now how to generate this data whose mean was actually, in that one, the mean was 30. Here, the mean was 30 mu. You can see, and the standard deviation is 4. But I will generate the data, normal data. Okay, here we are generating a normal data, or we are generating random numbers which follow normal distribution. Okay, so here, what's the meaning of this? Data generation means here first we will generate the random numbers, 1000 or whatever. Actually, I will generate. This is your will. You want to generate 1000, 1500, whatever. Okay. But I will generate whose mean is 6 and standard deviation is 1.897. I repeat, I am going to generate the random numbers or data which follow a normal distribution whose mean will be 6 rather than 30 and whose standard deviation will be 1.897. Why so? Because in the previous lecture on normal approximation to the binomial distribution, we had an example where the mean was 6 and the standard deviation was 1.897. So because of this, I will go with the same. So first of all, what I do, I open a new sheet. You can see here I had clicked here and I had opened a new sheet. Okay, one can very well see. So now here I write my x normal. Okay, my random variable. So here I write here that it is normal. Okay, normal. So just it's normal. So for that now. So now I will go into the data. Okay, here you can see this I will navigate or go to this data. You can see, and then data analysis. Okay, so here this tab is there, data analysis. So click on this. Okay, means first clicking on data and then on data analysis. Now you can see here there is a already selected random number generation. When one can see this is already blue colored random number generation. So just wait, please. Okay. So here for this now I will click on OK. Now you can see here it is mentioned that how many number of variables do we require. So I require only one random variable, that is X only. And how many random numbers do I require? If you see, if you had seen, observed earlier, there was mentioned it is 1000. So this is our will whether we take 1000 or 1500. So here I have taken 1500. Now I have to select the distribution, select the distribution. So once again here, the numbers, how many numbers you want to generate, this is your will, whether 1500 or 1000 or as per the assignment, okay, given to you. Now if I am clicking on distribution, you can see all these distributions, most of these we have already discussed. Uniform distribution, normal distribution, Bernoulli, binomial, Poisson. Okay, so here we are having normal distribution, so I'm selecting. So as soon as I select on normal distribution, because here we are generating a data which follows normal distribution. Similarly, if you want a data which follows Poisson distribution, that will be our next activity, then you will select Poisson. Okay. So as per the your requirement, means as per the distribution you require, you will select that. So here now normal. And now obviously, whenever we select any distribution, this the interface will ask for the parameters. We have already discussed that every distribution has parameters. So normal distribution, its parameters are mean, mu. Okay, so here it will be 6. And then standard deviation, it was 1.897. Okay. As I told you that the same mean and standard deviation was for the example which I had discussed in the previous lecture on normal approximation to binomial distribution. So now click on output range here. You can see. And now click here. Please mind, click here. And now if I click on this one, you can see I'm moving here. So if I click, so here it is 2, A2, this column. Okay, this has been selected. Means I need my output. Means I need these 1500 random numbers. I need my 1500 randomly generated numbers which follow normal distribution in this one. Okay. So obviously, what's the meaning of dollar here? Means this is fixed. Okay, so it is by default. There is we don't have much to do with this. So now if I click on OK, so one can see here this data is being generated. Okay, so here is that data. Okay, so now this data is there, and for this data, what we need its descriptive statistic first of all. And moreover, if you observe, if you bring it down, or you can see here. Okay, so it goes on and on and on and on. So there are total 1500 numbers. Okay, so it is from A2 to actually, if you see here, so here it is column A and row number 1501. Okay, so this is the data. So now uh, data once again means navigate to data, click on this, and then and data analysis, and again click. Now here there is a option of descriptive statistics. Okay, so I will click. So this descriptive statistics, data, and then data analysis and descriptive statistics. So okay. Now where is the input range? So input range is my this column. Okay, so I will select. Actually, I have clicked on this, the very first top cell, then Control Shift down arrow. Control Shift down arrow. So I am doing that. So my whole array or this whole column is selected, and one can see it is there. Okay. And now our data is grouped by columns. Yes, it is not by rows. Now labels in the first row. Yes. Okay. So see here. I'm repeating this bit. So click on this descriptive statistics. So input range. So where is the input range? This one. So again, this and labels in the first row. Okay. So now going back, there is some issue. Please wait. Please wait. I'm canceling this. So now data, and again this, and descriptive statistics. So input range, here is the input range. Okay, and labels in the first. Now next output range, and okay, so click here. Yeah, it is already there. Okay, now you can see I have done the same thing. Okay. Now labels in the first column, first row. Yes, labels in the first row, and our data is grouped by columns. Now, output range, where do I need my output? Okay, for descriptive statistics. Okay, so for that, if I select anyone, suppose I select here, so I need the here my output of descriptive statistics. Descriptive statistics, actually, this we have already done in our previous activities. That what's the maximum value in this whole range, minimum value, what's the mean, variance, standard error, okay, what is the kurtosis, all these things. So for that, I will click now on summary statistics. You can see I will click on summary statistics. Okay, and now, okay, so you can see here I have that descriptive statistics. So actually now Alt H O I. I have discussed this one once again. The Alt H O I, actually the column width will be automatically adjusted. Even this was already discussed during the lectures. Alt H O I to auto adjust the column width, and Alt H O A to adjust the row width. Okay, so now you can see here. Actually, this thing mean this is important, and I have selected, and keep press control should be pressed. CTRL, keep it pressing. Okay, keep it pressed, and then a standard deviation. Even this is selected now. Then this range is selected. Even this minimum, this is selected. Maximum is selected. Okay, so these are selected at the same time. For that, what you have to do, keep pressed this CTRL control, and one by one you can select. Okay, so actually these things are important. So I will control B, means I will make them bold. I am making them bold, and moreover I am giving them a good color. So here I am giving this color. Okay, so now these things are important for us. That mean, what is mean? 6.07. Now listen, actually the mean that we had taken, it was 6, and here it is 6.0047. Actually, the data that we have generated, although we will treat it as a population, I think you understand what's the meaning of population, the larger set about which we want to conclude something. So although we will treat this data as our population, but as per the Excel, okay, the Excel itself, it is still a sample. Okay, this means these 1500 entries, these 1500 randoms that we have generated from the Excel point of view, this software point of view, this is still a sample, but later on we will treat it as our population. Okay, so since it is a sample from Excel point of view, so that's why its mean will not be exactly 6, it will be close to 6. Similarly, standard deviation, actually our standard deviation was 1.87, but since once again from Excel point of view, it is still a sample of 1500 numbers, so which follow normal distribution. So that's why it is 1.9893. And now you can see what's the minimum value here? It is minus 0.75. And what's the maximum value here? It is 12.45. Means in this whole range, the minimum value is minus 0.75 and maximum value is 12.45. These values. And but the total range is this. Range means the maximum value minus minimum value. And the total sum is here and the total count is here, 1500. Okay. So this is the descriptive statistic. Even it was in the uh, assignment also. Okay, the descriptive statistics, this was there. Yeah, you can see here descriptive statistics. Okay, and please mind, this is not the assignment that we will have for our CA3. Actually, this is just, it has a part of our assignment also. Totally this will not be our assignment, and it has a part of this normal approximation to binomial distribution. Okay, now for the next one, what we need, yes, now I will use these things. What's the meaning? I will tell you that X binomial, and what's the meaning. So now I paste here, and once again Alt H O I. So yes, Now, X binomial, what's the meaning? X binomial, actually it will be zero, means number of successes. Look, here what was our X? It was normal, means this data you can see. Even it is our random variable, but here random variable is having a normal distribution. But even here our X is a random variable, which is having binomial distribution. Or here the random variable x, it follows normal distribution, and here our random variable will follow binomial distribution. So here 0, 1, and I select, and I drag now. Drag up to when I get up to 15 only. Why 15? Because once again, actually, this whole activity it is connected with the example that I discussed in the previous lecture. Okay. So n is 15 and bin. Now, how to decide about bin? Actually, even there, our bin was of length 1, that the interval length it was of its length was 1 unit. So here if you see what's the minimum value, it is minus 0.75. So here I will start from minus 1, okay, for bin. Okay, then it will be 0. Okay, and then now I select, and now I drag. Okay, so this is my bin. Okay, so since I need next, so this one. Bin means the interval length, the interval length. So how to decide? Here the minimum value is minus zero point 0.7. So I will start from minus 1. And actually, look, the total range is 13. This total range is 13. Actually, this bin, it is going to decide our number of rectangles, number of intervals, since it is interval length. Just I show you in the previous one, if you see here. Yes, you can see here. Here the bin, you can see the bin is from minus 2, minus 1, 0 up to 15. So you can see here, this is the bin, this interval length, 1, 2, 3, 4. This is as per our the previous means the lecture on normal approximation. Okay, so this is same thing. Okay, so here this is the bin or interval length. And here, if you see once again, the minimum value was minus 1 and maximum was 12. Actually, here the data was again, actually, it is randomly generated data. So every time we generate a data, its minimum and maximum value will be different because it is randomly generated. Okay. So here now, actually, we have to decide about this win very carefully. For example, suppose our range is say having 33. Here it is 13. Here range is 13. Suppose our range comes close to say 40. Range comes close to 40 means minimum maximum value minus minimum value. So for 40, the good bin will be of 2. 2 whose length should be 2 means starting from minus 1. Okay, minus 1, then I should jump to 1. Okay, and then if I select both, and now if I drag, okay, so you can see, so if I go up to 40, so it will be like this, that minus 1, 1, 3, 5, 7. So if our range is of 40, okay, then this will be the good bin. Why so? Because the number of actually this bin, it will decide our number of rectangles, okay, or number of intervals. So good number of intervals are 10 to 12 to analyze 10 to 12. Otherwise, if number of intervals or number of these rectangles, they are more, so means beyond 12 or 13, means if we have 20, 25, even that is also okay, but then obviously it will become typical for us to analyze the data. Okay. So rest depends upon you. If you are okay with the more number of rectangles, okay, then it's there is no issue. Okay, so here now, what we need now, once again here, histogram. If you see here. histogram based on the generate the histogram of the data set. So now uh, go to data and then data analysis, and then here it is histogram. One can see histogram. Here it is histogram. You can see here histogram. And now okay. Okay. Now input range, once again, the input range is this one. This you can see this one. So here, okay, means our original normal data. So control shift down arrow. And now bin range. Now you can say it is asking for bin range. Okay. So here it is my bin range. Okay. So once again, what is this bin? Actually, the length of the interval, okay, which is going to decide our number of rectangles or number of histograms. Okay. So if the total range is 40, then your bin you can take two. If your range is 100, then you can take it as three. Okay. Why so? Because 100 divided by 3, if your range, I am talking about this range. If range is 100, actually the good choice of bin will be 4, because 100 divided by 4, it will be 25. 100 divided by 4, 25 means there will be 25 rectangles in the histogram. So here, since our range is 13, you can see range is 13, and our bin is of 1 unit. So here it will be 13 rectangles. If our range is say 50, range is 50 means maximum value minus minimum value is 50, 50. Then a good choice of bin will be 2 unit, because 50 divided by 2, it will be 25. So our histogram, what I am talking about, this histogram is wait. Uh, yeah, so this one, so it will have how many? 25 such rectangles. Okay, so even here you can see the range is 13 and the bin is of 1 unit. So how many rectangles are there? There are 13 almost. Okay, you can see it is almost, because where the probability is 0, it is not showing any this rectangle or histogram. Okay, for the lower probabilities, let me check if I can. Yeah, now you can see. Okay, so this thing. So now this one here. Wait. Okay, so here this and labels, yes, output this. So if I now click, please mind, click here first. Okay, so where do I need my output? So if I click here, so my output will be here in this column H1. And now just okay. So here it is, that one, the histogram. So first of all, we will delete. Now here it is the bin, once again the bin. And now what's the meaning of this frequency? What's the value meaning of this 6? The meaning is that in this data, there are 6 numbers which are greater than 0 and less than 1. What is the meaning of this 6? That in our given data, there are 6 numbers which are greater than 0 and less than 1. What is the meaning of this 221? That in this data, there are 221 numbers which are greater than 4 but less than 5. Okay. What is the meaning of this 222? That in this data, okay, there are 222 numbers which are greater than 7 but less than 8. Okay, so this we can verify, although it is not a part of the activity, but just for the knowledge of Excel. Press equal, selecting this cell. Now count ifs. Here you can see count ifs. Okay. So count ifs. So here he is asking, it is asking the criteria range. So criteria range is this one. Okay. So this is the criteria range. So this one. So it is selected criteria range. And again, going back. So criteria range. And in this range, now I will put comma. So criteria range is selected. Put comma. Now it is asking criteria. So what's the criteria? So here criteria for that, these double columns and go back inside this. Here greater than, if I say greater than and 5, greater than and 5. Okay, so this is my first criteria. Actually, I am counting those numbers in this range, in the given range, this range, which are greater than 5 but less than 6. Okay, so this is my first criteria, that criteria 1. Now, once again, put comma. Now, again, it is asking criteria 2 range. So, obviously, this is the same range. Okay, so again, copy, I will copy. Okay, the range is still same, criteria range, you can see. And now, here, what is the criteria? Now my criteria, this columns inverted. Here, it is less than, okay, and less than and 6. Okay, so this is my second criteria. Means in the given range, in this range, okay, I want those numbers which are greater than and equal to 5, and or even you can see here rather than this, here you can greater than equal, okay, and here instead of this less than and equal. Okay, you can do this one also. So here close the bracket and enter. Okay, there is some issue. I think I have made some mistake. Great. Oh, yeah. Here, this 5 should be here. Yes, yes, yes. This 5 should be here and greater than equal to 5. And actually, even here, 6 means this 5 and 6 now, it should be inside the column, these inverted commas. Now, enter. Now, you can see 304. Okay, so that is this 304. Okay. So now, this is our this histogram is there, and now what we need, now we have to using this frequency table calculate the empirical probability distribution. What is empirical probability distribution? Means the ordinary probability. Actually, we find a probability by various ways. One is the ordinary way. What is the ordinary way? The total number of favorable cases divided by the total number of cases, or we calculate by normal distribution. Here you see that compute the probabilities of each bin using normal distribution function. Even we calculate probabilities by using binomial distribution. So we will do all this. So go through this assignment. Okay. So all the points I am discussing now. So now for that, I am taking the help of this one. So what I am doing here, I am just copying these headings only, just these headings. Okay. So here now I paste these, and once again, Alt HOI to adjust the column width. Okay. Now FX. This is the empirical probability. Empirical means this is equal to this value, okay, and divide by what? 1500. Why so? What is this zero? It is the total number of favorable cases divided by 1500, total number of cases, okay, outputs. And if I press enter, so this is 0. And now if I select, and now either you double tap, okay, or you drag. And now I will just drag so that I can have more means the good values of probabilities. Now, what's the meaning? If you click on this, so read here, please read here. It is I4 divided by 1500. If you click here, it is I5 divided by 1500 going on. Means this is the empirical probability. Means here how many numbers, the number probability of the numbers, in this range, in this our data, the probability of the numbers in this data which are greater than 2, greater than equal to 2, but less than 3. I repeat, what this represents. This is the ordinary probability. This is the ordinary probability, empirical probability of those numbers, okay, which are in this data, which are greater than equal to 2 but less than equal to 3. So this is the ordinary probability. Now we will find the probability, okay, of the same numbers but by normal approximation. So equal NORM, normal distribution. Now it is X. It is asking for X, the value. So what's the value here? Here the value is this one, -1. And here, this is my value. I will click means H2, the value in this cell H2 I have selected. So now plus 0.5, 0.5. What is this 0.5? Actually, this is our correction factor. This I had discussed in the previous video on normal approximation to binomial distribution. Please do watch. And then comma. Now mean, what was the mean? Mean was 6 and standard deviation, it was 1.897 and cumulative. Yes, I do need cumulative, so I will either you type true or 1 and then this one close. Now I will copy and minus paste and only change here. If you see here, it is H2 plus 0.5 minus H2. Here, instead of plus, I will do minus. Only this. Don't worry, I will explain why I am doing so. Actually, if you have watched the previous lecture, then you will be getting that why I am doing. So now this thing and press enter. And now click and once again double click or drag. So now this is the whole thing. And first of all, you can see what's the total here. It is 0.999. That's the confirmation that actually the sum of all probabilities, it must be 1. This sum of all probabilities must be 1. So here it is 1. Very close to 1, not exactly 1. Okay, because these are just approximated values. Now, why we were doing so, this -1, sorry, plus 0.5, minus 0.5. So for that, if you see here, actually I discussed this one in the lecture. So, so here if you see, if I need this one, so if I need this value at here, 4, at 4. So for that, what I need this point, 4.5, okay, means up to 4 point, oh, wait, I should not. Okay. So now, I need the probability at 4. So for that, what I will do, I will have up to here 4.5, means up to this 4.5, this entire probability. This 4 point up to 4.5 means this probability that z is less than 4.5, okay, minus probability z is less than 3.5, okay, that is this one. 3.5 is this point, that is 3.5, okay. So that's why for that what we are doing, 4 plus 0.5, that, and z less than means CDF value, okay, cumulative, and minus z less than 3.5 means 4 minus 0.5. Okay, so this is the concept that I discussed. Okay, so here this 0.5 is the continuity correction. Okay. For more detail, if you want to go into the detail, please do watch the previous lecture. You will understand each and everything. Okay. So here now we will find the probability by using binomial distribution also. Okay, and that will be obviously the exact probability. So here once now equal BINO, binomial distribution. Now it is asking for number of successes. Number what we say under the score S means how many successes. Where are my successes? So successes are here. Okay, so here it is my success. Okay, numbers. So here then trials, how many trials were there? 15. Okay. And probability of success, you can see the probability of success that was 0.4. Okay. Now the gain comma. Okay. Please mind each and everything is important. The commas are important means our command should be correct. Okay, and now cumulative, yes. Okay, I don't need cumulative. I can carry on with the probability mass function here. So I am selecting this false or zero, bracket close and enter. Okay, so this one, this is the value, and now this I double click. So this one, and yeah, here's something wrong. Why wrong? How I know there is something wrong? Because if here the sum was 1.00 means it is more than 1. It can't be more than 1. Actually, this entry should not have been here. Why? Because our it is going up to 15, 0 to 15. Please mind. Okay. So if you click on here now, this one and see, it is total sum is 1. Total sum is 1. Actually, this value, if you click, and now you see here, here it is binomial distribution F17. F17 means my X number of successes. It is F17. You can see F17. You can see this is 17 and this is F17. It is up to F17. I repeat. Okay. So otherwise it was going up to F18. So there is nothing in F18. Okay. So this is Fx. Now, uh, uh, this one, select the this bin, please wait. Yeah, we need this fx, this one. Now we need this fx and this, yeah, it is okay. So it is the bin now. Hmm, select this. Okay, and keep pressing control. After selecting this, keep pressing control and click and control shift down arrow. Means uh, you have to select these two columns, one column of bin and one column of fx, the probability calculated by binomial distribution. I repeat, you have to select these two columns. Okay, for that first select one column. Okay, then control, keep pressing control CTRL. And if I am not wrong, in the MacBooks by Apple, it will be command. Okay, rather than CTRL control. Okay, so this is what we call the controlled selecting. So now insert, okay. So you can see insert and then column here you can see and press click on this, just this. Okay. So now click and drag it to aside. Click and drag it to aside. Wait, please. Oh, no. Click here and drag it. Okay. So I am dragging more. Again, drag means just click outside means on this white area, and once this four headed four headed symbol is there, so you can drag. Now look, what are these blue colored histograms rectangles? They are bin, and here the probability which is by this brown, light brown color, it is very small. So if I show you, you can see it is very small. And actually, if you have observed, we don't require bin in vertical direction. Actually, our bin should be in the horizontal direction. We know that bin is going to decide our number of rectangles or number of histograms. So click on any of these blue rectangles. Bring the cursor and click. Now bubbles are there. And now right click and select data. Okay, select the data. Now here bin, you can see bin. I don't need bin in the vertical direction, so I remove. You can see as I clicked on this remove means bin is removed, and now it has only affects the probabilities due to binomial distribution. Okay, and now in the horizontal, what I need bin here. Okay, so clicked, and now here, what is the axis label range? That is this one. Here, this. Please mind. Here, this pin. And now Control Shift down arrow. So means on the horizontal, I need this thing. And click OK. Okay, and now again click OK. Now you can see, oh, there's some mistake. Please wait, please wait. Actually, what's the mistake? That bin, this word should not be there. So click on any of these rectangles, right click, select data. Here, edit. Actually, it should start from -1. So then this one, okay, okay, and now this one. Now it is okay. Okay. And now, once again, click for the bubbles, means click on any of these histograms, rectangles. Uh, Bubbles are there. Mm, right click, format data series here. And now, no gap, no gap, click and drag. You can see. Okay, we don't need any gap, you can see. Okay. And now fill. Here it is fill, and here vary colors by point. Vary colors by point, and close. Now you can see this is the same histogram or rectangle which we had discussed in the previous lecture. That is, I am talking about this. Okay. So now we have to draw the same. This is the probabilities by binomial distribution. Now we have to draw. We need the probabilities. Actually, here I told here there are two graphs now. One graph by binomial distribution, which is histograms. Now one is by this blue colored curve, which is a normal probability curve. Sorry. How to draw this normal probability curve? So now uh, we will select this. Wait. Actually, I'm talking about this one. Yes, this type of effects. And yeah. So now select this bin, this one. Then keep pressing Control. Okay. Then this column, Control Shift down. Then again, CTRL, keep pressed. Then this one, Control Shift, this. Means you have to select these three columns. Okay, now insert and then this line. Okay, so here I am having this one, means line chart. Okay, so this one clicked. And now actually, this blue colored, it is bin. Once again, I don't need bin in this direction. Actually, bin should be in the horizontal, it should be along the horizontal axis. Actually, in vertical, what I need this fx, which is the probability, empirical probability, and I need the probability due to normal distribution. So, bring the cursor on this blue colored line and and click on this. Bubbles are there. Okay, you can see. And now right click. Okay, and now select data. Select the data. Okay, and now select the data. Now this bin, it has to be removed because in vertical I need only fx, the ordinary probabilities, empirical probabilities, and I need only normal approximation. So it is removed, you can see. Okay. And now I need a bin in here. Okay. So edit. And now, uh, yes, here, this one. Okay. So, okay. And you can, okay. Okay. So here is the thing. Oh, wait. So actually, once this two-headed arrow is there, na, this two-headed arrow, then you can drag. You can see here there are three dots. So now this light blue color graph, it is the ordinary probability. Okay, and this the gray colored is normal approximation. And actually, here, this normal approximation, this curve was due to this gray colored uh, curve. Okay, so our this graph, it was superimposition of the two graphs, one due to binomial distribution, the histograms, and one due to the normal approximation. Okay. So once again, you have to watch the previous lecture. Okay. Otherwise, you may not be getting the whole concept. Okay. So now, actually, if you see that our empirical effects, okay, the ordinary probabilities, okay, even they are having normal, the curve or curve like normal distribution because our data was have already having, it was our data which we generated in the starting. It was actually normally distributed. So that's why both the curves, ordinary probabilities, affects empirical probabilities, and the one by normal approximation. Yeah, both are having a bell-shaped curve, means the normal probability curve. Now, here we have this thing that here x, random variable, it is life of any physical system. Here x, it is the random variable which denotes the life of any physical system. Okay, and whose mean is 40 months, means expected value of x is 40 months, means this is the average life of that physical system, and standard deviation is 6.3 months. Okay. So now how to get these values? So here equal, sorry, here means probability that life x is greater than equal to 30, means what is this thing? Probability that actually this is probability that x is greater than equal to 32. So we need this, means this one, and means this one, and this one. They both are same. Okay. So if I mark them bold. Okay. Now here, this one, equal normal distribution. Okay. Now it is asking for x. What is x? X is 32. Okay. Actually, here x is 32, but I should have started with 1. 1 minus normal distribution. Here x, it is 32. Then what's the mean? Mean is 40. Then what's the standard deviation? Standard deviation is 6.3. And cumulative, yes, cumulative true. And this one true. Okay, so then close and then enter. So you can see this value. Now, what's the meaning of this command? Why we have done so? So, wait, please. Actually, oh, this is the case. Actually, one thing, this X, which is the life of the physical system, life in months, this X, it is the life in months of any physical system. It follows normal distribution. Okay. With mean mu, that was 40 and standard deviation was 6.3. This X, it is the fact. So here, if I draw here, x is 40. Obviously, here z will be 0. Okay, what is z or z? This is x minus 40 mu divided by sigma 6.3. And actually, what we need, I think I should have made it better. Please wait. Actually, we needed, yeah, x greater than equal to 32. So here x is 32. We needed this probability. Okay. This probability or area. Okay. So here the probability and area, they are same. So what's the total area? The total area, please wait. Yeah. So the total area, please mind this total area is 1 minus this area. Now, for that, suppose I take this one minus actually this one area. Okay. So, what is this area? Probability x less than equal to 32. Okay. Now, what is this thing? It is f at 32. And what is this F? It is the CDF of normal distribution. This is the CDF of normal distribution. So that's why we have done so. Okay. So that's why uh, it was this, that it is 1 minus normal distribution. The value was 32. Mean was 40. Okay. And standard deviation going on like that. So now here, this, so this is actually okay, wait. Yeah. So actually, this one, oh, I'm making a mistake. Yeah, this actually, this is now, mm, this actually here, life is X. Okay. So, instead of 32, here we have 28. Okay. So if I just remove, so here x is 28. And obviously we need this area now, this yellow colored. So it is simply probability x less than equal to 28, which is nothing but f at 28. Okay, what is this f? The CDF of normal distribution. Actually, these basics I have already discussed. So now here equal normal distribution, double click. What is x? 28. And now comma mean is 40, then comma, and then this one, then yes, one, this, and then this, it is done. Okay. So what's the meaning of all these? That if X is the life, X is the life of any physical system with the mean value, means average value is 40 months, means on an average one such component of this physical system, one such component of physical system whose average life is 40 months, then the probability that one such component will have greater than equal to 32 months. So what is this thing? This thing, the probability that one such component, okay, its life is greater than equal to 32, it is this one. And similarly, this is for less than equal to 28. And now this one, so it is here. So instead of this, we will have x. Okay, so it is look normal distribution, normal. Okay, okay, and x now. X is actually first I will take 49. Okay, comma, then again 40, again this, and 1. And I will copy it now. I will copy, oh wait, I will copy this whole. I have double clicked, copy, and minus, paste. And instead of 49, what I will do here, I will have 37 here. And now enter, click enter, only this thing. So you can see. So this is the probability that a single component of this physical system, its life is between 37 to 49 months. It is this one. So it is not hard to understand now. So basically, once again, what we need, one value was 37. Mm, One value was 37. So it will be to the left of 40. Okay, the average value. Okay, and the another value was 49, means this value will be somewhat here, x equal to 49. Okay, means it is here. Now we need this area. Okay, this area, you can see. So for that, I have taken this entire left. I have taken the entire left of 49. Okay, the entire left of 49 means this is f at 49 minus the entire left of 37. Okay, so this is actually probability that x, okay, which is less than equal to 49 minus probability x is less than equal to 37. Okay, so that's why. Now, what about this? Actually, we have to wait. Find k means such that this probability is 0.70, 0.70. So for that, actually, yes. So x is 40 and we need, wait. So x less than k, which is 0.70. So this k, it must be here, somewhat here. Here it must be k. Okay. Means we need this area or probability equal to 0.70. This K, it will be here. Why it can't be this side? Why it can't be on the left side of 40? Because if it is this side, suppose it is this side, here it is x equal to K, then this probability means to the entire left of K, it can't be 0.70. Actually, it will be less than zero point 0.5 because this area, uh, the area to the left of 40, area to the left of 40, it is zero point 0.5. Okay, so this is a symmetry. We are using symmetry of normal distribution. So that's why it is here. Okay, so now uh, for this, actually, listen, equal normal, but this time normal inverse, normal inverse. And what's the probability? It is 0.70. You can see probability 0.7. And then what's the mean? 40. And what's the standard deviation? 6.3. Means whatever it is asking, it asked first probability. So I have entered probability, then it asked for mean. So enter the mean, then standard deviation, enter the standard deviation, bracket closed, and enter, it is this value. Means uh, one such component, its life will be less than 43.30. One such component, its life will be less than 43.30 months. Its probability is 0.70. Now, for this, actually, probability, yeah, I think I can 0.25. Once again, uh, probability x greater than k, it will be, we need 0.25. Now, again, this k, it will be on this side, means on the right side of 40. It can't be on the left side of 40. Why? Because this probability now, wait, please. Yeah. Uh, this probability or area, we needed 0.25. Okay, this is 0.25. Now, if it is on this side, means this case here, means at this point, it is at here, then this probability, x greater than k, it can't be 0.25, actually it will be greater than 0.5. Okay, because this area is actually 0.5 plus something more, it can't, it will be more than 0.5. So now for this, what we will do, 1 minus probability x less than equal to k. What will be that? 0.75. Okay, so we will use this. So, what I will do, please mind, it is equal to normal, once again, inverse. Okay, normal inverse. And what's the probability now? 0.75. Okay, the probability is 0.75, and mean once again 40 and 6.3. Okay, then close that, then this one. Okay, so if I am using ordinary normal distribution, then I am finding the probability for a given value of x. Okay. And if I am using, when I will use normal, inverse normal, if the probability is given, if the probability is given, here you can see the probability is given, and I have to find the value of x. Okay. And the value of z for x35, it is simple that it is equal to bracket, what is the value? 35 minus 40, sorry, x minus mu. Yeah, sorry, 35 minus 40, bracket close, and divide by 6.3 and press enter. This value, please mind, it should have been negative here, not positive. Negative, there's a mistake here. Why? The value of z for x35. So 35 minus 40. So you can see 35 minus 40 divided by this. Thank you.